रंजित ये है ना एक बार कोई
Welcome back, everyone. I request all the delegates to please settle down so that we may begin with the keynote session.
लेकिन वो शेयर करना पड़ेगा स्क्रीन शेयर करना
नहीं है सर।
लिंक को हम लोग स्टॉप नहीं करना लिंक शेयर किया उसमें
कोई दिक्कत नहीं, जो एक बार देखा होगा ना उसको एप्लीकेट करने में क्या होगा।
फिर
ज्वाइनिंग
नो एनीबॉडी
ये कुछ
Yes, my name is Dr. Skyly.
इसमें नहीं आएगा।
ये फंक्शन नहीं ऊपर
हाँ सर, हम फुल है।
मेरा व्हाट्सएप खोल लीजिए।
आपको लिंक चाहिए क्या?
हाँ हाँ, व्हाट्सएप मेरा खोलिए। सर का पीपीटी एक अपलोड करना है।
आप हमको इनको भेज दीजिए।
सर हमको भेज देते व्हाट्सएप यहाँ पे साइनिंग ऑलरेडी है फोन चल रहे ये सर पेन ड्राइव रिमूव फुल पेन ड्राइव लगा रहने पोस्ट कहाँ से सुधरी गया था पेन
हाँ, क्या हुआ? स्टार्ट किया? हाँ,
स्टार्ट कहाँ गया
नहीं स्टार्ट नहीं करनी, अभी जो कीनोट होगा।
सर इनका भी ये नॉट जॉइंट है सर।
अरे उनका नहीं, ये व्हाट्सएप खोले आप। हाँ मेरा ही खोल लीजिए ना, आप खोलिए ना मेरा व्हाट्सएप, यहाँ डाउनलोड हो जाएगा। मेरे में इंटरनेट स्पीड स्लो है। वेब खोलिए, वेब।
ये है तो ऊपर यार
नहीं हम खोला कर हर चीज जो है इतना स्लो है। वो मैंने बोला था ना इंटरनेट देख लेने का आपको, लेकिन
स्क्रीन को डिस्कनेक्ट कर दीजिए स्क्रीन डिसेबल कर
2 मिनट होगा।
ऑफ ही होगा ये स्क्रीन ऑफ नहीं सर
हाँ ये तो नेट ही नहीं है, क्या फिक्स है? इनका टॉक सर का अपलोड करना है, पीपीटी अपलोड करना है।
कंप्यूटर ऑन पे
Sir, this is your. किसका है ये?
सब इसमें लगाने वाला नहीं वही
ये तो इंटरनेट ही नहीं है, मैं क्या करूं बताइए। कहाँ से ले लें पेन ड्राइव? कहाँ? आइए। यहाँ नहीं खुलेगा।
आप ये सर एक बार से फैक्ट्री बात है सर आगे सर आगे
हाँ नहीं कस्ट। इसके बाद किसका है उसको पीपीटी सब ले लीजिए।
स्टार्ट करा दें
हाँ
वो पॉइंटर कहाँ पे
यही है ना?
वंडर।
पॉइंटर कहाँ पे
हाँ जुड़ेंगे।
ये दोनों खोल दीजिए उनका बायो वाला भी खोल दीजिए उनका पीपीटी जो है वो भी खोल दीजिए साथ में दो खुले हैं एक ही खुला होगा
एक ही खुला होगा।
अच्छा नहीं बायो वाला
आपके पास है?
बायो वाला ठीक है जस्ट चलिए सर को लगा
Very good afternoon, ladies and gentlemen. So as we reassemble for the keynote session of this conference, I again welcome you all on this auspicious occasion of Icgeid that is being hosted in Iit Patna by the Department of Civil and Environmental Engineering. I welcome all the eminent guests for the occasion. Now, as we move ahead, as we proceed, we are fortunate to have with us Shri R.K. Dhiman, the Additional Director General of the Border Roads Organization, India. I request the delegates to please maintain the decorum of the hall. Shri R.K. Dhiman, Vishisht Seva Medal, ADG, Border Roads Organization, New Delhi stands as a beacon of excellence in the field of civil engineering. His profound insights and expertise were showcased brilliantly during the Industry Academia Expert Lecture Week at the Punjab Engineering College, Chandigarh, where he delivered a captivating lecture on bridge construction challenges in hilly areas on the 14th of September 2023. Shri R.K. Dhiman's outstanding contributions were underscored by the recognition bestowed upon the Border Roads Organization, Ministry of Defense, for the Atal Tunnel, the world's longest highway tunnel. The Best Project of the Year 2022 trophy was a testament to the exceptional leadership and engineering prowess demonstrated by Shri R.K. Dhiman and his team. This achievement not only brings honor to him personally, but also elevates the prestige of the entire civil engineering community in the country and the world. I now request Shri R.K. Dhiman to please come up this stage and deliver his talk. Please put your hands together.
तो सीट पे रहो। ठीक है स्लाइड। Good morning once again, and we'll start with the challenges what we are facing in the border road organization, the bridge construction, and so this will be a sequence of presentation. First, I'll just give a overview of border road organization, then construction challenges, The well foundation, which we have oftenly used for our mid piers in the bridges, and the construction was so difficult in few time. We have used the pneumatic sinking, which is not being used in the country now. We are going with a pile now. Then gray area of foundation construction is the scour depth calculation. As I was mentioning in the previous lecture, that for calculation of scour in case of sandy soil, we have a ready-made formula. But when it comes to the bouldery wet scar, there is no formula in the country. So we had made a little start with our data collection. So I would have a little intervention from the institute, but we can do further in this. Then view suggestion this. So this is just overview of border road organization. If you see, we are in most of the eastern states, all the 8 states in northeast, we are working there. Jammu Kashmir, Himachal Pradesh, and part of Rajasthan. Uttarakhand, of course, we are there. And previously we have been called for work where there's a tough site. Maybe we have worked in Tamil Nadu. Incidentally, we have worked near Dhanbad also for few roads. And in Gwalior also, nearby, whenever there is a certain road. And we worked in Bombay also. There are a few roads where there are certain other issues. Then government requisition, BRO expertise, and we work there. So this is just to highlight our work in the country, especially in different type of road length. I told you that we have made a 63,000 kilometer of road and 900 of bridges. And they are in different terrain, different difficulty. Because I just want to share with you that when we work in hilly area, each bridge is a different. Every foundation site is a different. We can't replicate. It can be superstructure we can make as a standard, but when it comes to the substructure or abutment, it's a little difficult to. Then this is a few challenges which I have, few things I have told that hard area. Then high altitude is another problem because I was mentioning that fitness standard of the people when we work in Leh and around, and especially the even altitude is 3,000 plus. That is very, very important to work with because it affects the efficiency of the people. Then similarly, these are the few Western projects, and these our name is also catchy. If you go somewhere, some beacon, some park, Himank, and that is also very attractive. And this logo is also, you can see with the logo, you will understand this is a BRO projects. So now you just see the challenges like when we are in Jojla pass is there, there's a lot of snow, almost 5-6 months it is blocked. So now we are constructing Jojla tunnel. There's almost 13 kilometer under construction. I think around 6 kilometer digging has been done. So this is another 3-4 years. This will be completed. But we have been mandated to keep it open in this season so that we can assist the construction company for the large part of the year. Otherwise, normally it remain closed for 4-5 months. Then the few location where the extreme temperature, we had constructed a tunnel in Sela Pass. Sela is in the bay to Tawang. So that is also a very difficult site and somehow it is completed. Very soon it will be inaugurated, this tunnel. Then there is a hard rock. This is one of the road which we are cutting, this Gadiawad Lipu Lake. This is in Uttarakhand. This road will lead to Mansarovar Jatra. We have been hearing that it will be very easy to go to Mansarovar by Uttarakhand. So this is the approach road we are working there. Similarly, there is a Saser Barangza. This is a road I was mentioning. The approach to this road. This is in permafrost condition. Throughout the year, in the June also, you can't have snow cannot be removed. There is a abundance accumulation of the snow in that top of the pass. Tunnel is another very interesting area. We have a plan up to June 20. We had only 2 tunnel, but now almost 10 tunnel are under construction now. So they are in different stages, and few are in the planning. So this is one of the very interesting area for the researcher also, if they want to get integrated directly or indirectly with us, this can be. And I can only say that tunneling is feature in the country now. Like I was hearing Professor Rao, IIT Delhi, he oftenly mentioned the underground is feature. So that is what lot of structure we are making, maybe in the metro and hill area. Of course, tunneling is the requirement. These are the basically upcoming tunnel, mostly in Ladakh and Sikkim area. Then slope stabilization, of course, our site are very difficult. We have attempted at few locations. This is quite satisfying to be having such arrangement on the ground. Then this is the approach to our Atal Tunnel. This is a around 13-kilometer approach. This is very tough. We have made lot of snow galleries for this. So now it is a structure like a cut and cover tunnel, but there is a accumulation of snow, debris that's coming. So this special design was done for this. So this has been completed. Now, if some of you have seen Atal Tunnel, so this is in the approach of the Atal Tunnel. So these are the few other technology where we have tried at a different location based on this. So in fact, we are interested because since we are, our sites are very far from the mainland. So we want to have the tailor-made solution based on what is available in the neighborhood. If we can have some solution based on that, that will be very interesting for us. Then there are a few other things which we have done. Recently, steel slag we have used in Arunachal Pradesh also as a trial. Plastic waste is also being tried at a few locations in this. So these are the few bridges. This is the first bridge in the country. We have used micropile. No, I don't think we have used micropile any of the bridge in the country. So we have used at a two location in Ladakh area. The one bridge has been recently completed during September this year. That is again in the minus temperature range. The minus temperature in that area is around 40 in the peak season. Then few bridges we have tried. This is a modular bridge. Garden Reach is a company in Calcutta, work under Ministry of Defense. They have been making Bailey Bridge, which we call a emergency bridge, temporary bridge. So that were earlier a single lane. Now they have come with the solution of double lane. So we have used this. So these are the other few things which precast we have done to reduce the time at few location. So this is just a overview of what we have been doing. Another very difficult thing for us whenever there is snowfall in the road stretches, it's very difficult to find the existing road. When we have to clear the snow, when our dozer operator has to go, it is very, very difficult to identify because whole stretch get filled with this. Because one side is a valley, other side is a hill. Little bit mistake can lead to problem. So then we have a solution, the route guidance. This is being worked out. And now there is a perhaps technology, if we have a route already surveyed, now you put on the instrument when we go for the snow clearance, the route will be identified, the movement of equipment can be controlled with the full safety. So that trial we had done. So if it comes through, we would like to have whatever equipment we are holding, we want to have put this on the old equipment, and we are requesting the company in the industry, if they can put a system that route identification is possible for the new equipment, that can also be very useful. Now comes to the basic topic, which this was the just overview of BRO, AOR responsibility. And then now I am coming specifically to the bridges. So what are our challenges in this? So we know that there's a lot of monsoon, flash flood, earthquakes, then snowfall. Then foundation strata is the biggest problem for us because this is not a common for other organization working in the country. This you can see one of the bridge in Uttarakhand, 1978. This bridge is 90 meter, truss height was 16 meter. So when there is a blockage on the downstream, there's a lot of debris. It is a dam formation. The top bracing of the bridge became the bed level. So there was a accumulation around 15, 16 meter. So this is the one of the site which we are in. This is another bridge in Sikkim. You can see whole bridge is full of boulders and all this. It's very difficult to remove very easily unless you have a good equipment. This is another view of this. Another site in Arunachal Pradesh where bridge get blocked with the debris flowing. This I'm taking in spite of whatever the guideline given to us when we work in hill areas, such forecast things happen there. This is another problem. So we have learned in some time in the plain area also, if the bridge is requirement of X length, if you make a longer bridge, that is also dangerous. Why it is dangerous? If this flow is carrying some silt, it will start depositing, then it get deposited and bridge get blocked. That type issue is also being faced there. Similar, there is one bridge in Himachal there, there is abutment. This is a bridge in Punjab near Hoshiarpur. This is also excessive scar. Now, this bridge is in Uttarakhand. 1991, when there's earthquake, Gavana Bridge, this bridge got shrunk in a line of traffic. So this just fallen on the cross section. This is another bridge where wearing got dislocated there. This bridge is very near to Jammu town. This we call it the excessive flow. This almost the raft foundation base is visible now. Now we have done a repair for this, and new bridge is also made in the neighborhood. These are the bridges, two bridges that recently got, superstructure got dislocated. This with the washed away with the flood. Now what is happening when you have a very limited choice to make a road along the hill contour, then upstream side the slope is steep. We are saying that this is a unstable hill and we are doing a lot of stabilization. When it comes to Nala, so lot of debris sometimes cut, it takes away the superstructure as something is picked up and thrown into the river. So there's the one box gutter of 45-meter span. It was just converted into pieces. You can't identify it. All pieces given with the force of water, it was taken away and just gone downstream. This is the recent, this year. This is Jumma Bridge near Joshimath. So this is the big boulder which hit the superstructure, and after 2 hours, this bridge was again washed away. So this is what is happening. This is another rainy bridge when we had a tragedy last 2 years back in near Joshimath. One of our bridge got washed away. The pier got sheared basically from the bed. So these are the basically, apart from this, working condition are also very limited, because in northeast you have a only 5-6 months to work. In western side you have a snow, so you can't work. It's a few projects of us like in Rajasthan you can work for a little longer period. Otherwise, a BRO only half a year is available in the major projects. Then the important bridge planning we are generally seeing in our area, the first of all is the easy accessibility. There are number of bridges where you can't have approachability from both ends. Those type of things are also there. Then stable bank is there, adequate working space. Then few geometric requirement which you should be keeping in mind. Another thing we are seeing that in the hilly area when we are making the bridges, especially in the midstream, the few of bridges, when the boulder comes, it hit the pier. Lot of damages has been done to the bridge foundation. So that is also in record. Then the code has been, this is highlighted in the code that we need to put a steel lining on the outside of the bell foundation. So those type of thing also we have done in few cases. So bell foundation, of course, you know, this is not, I'll not touch this. I'll just come to, this is basically when we have been working for the boulder bed strata. So normal sinking is not an issue with us. When you are not able to reach the desired foundation level, we need to take our well further down. It become very difficult. Why? Because the desirable requirement to reach the level is not possible. But with our 20 bridges data, we have find the whatever design has been done, this is based on pre-investigation. Whatever the C5 value was given, it was around 25 value of 5 and similarly gamma and all this. But when we say strata is tough, that means it is a good for us. Whenever say we are not able to sink our well, why? Because the strata on the ground is very tough. So we have analyzed if a tough strata is there, it is a good for engineer. If I want to found my foundation, if tough strata is good for us, like the bridges which we have made over river Ganges, from Haridwar to maybe up to Patna, there may be 20 bridges. The depth of foundation is around 40 to 50 meters for each pier. Even in Patna also, when Ganga Bridge was made in 1986, each well was sunk around 56, 55 meter from the lowest well level. This was in the sandy and it is very easy also to. But when we are in upper reaches, we are not supposed to go down. But that confidence can come to me from the geotechnical data. If you give me the phi value 25, I cannot terminate my foundation at that time. So in few of the cases, after the construction difficulty, we have gone down, we have taken a reinvestigation at the ground, at a mid-level. Why? To reassess the data. The strata which was indicated in the pre-investigation, it is not the same but I am getting. So in that case, I have to reinvestigation. Now if phi value is taken 25 during investigation, but when it is really coming 35, 36, this will change the foundation level to 4-5 meter. If there's a 10 number of foundation, it's a lot of changes. So that is how we have to see micro level. I'll only request that the people seeing the strata, they should be able to tell us what can be the phi value of this. Because the report which we are getting from the in our bridges, right now we are having bridges under construction, around 200 plus bridges under construction in BRO in different sites. We are getting investigation done. You cite what is the ground data and what the report we are getting, it's not a matching. So that is why the topic which we have taken as a here in the institute is very good for our future, because we need to think micro level that if it's a sand, phi cannot be more than this. If it's a gravel, it cannot be more than, and if it's a boulder and grave, what can? If you give me this data correctly, I think there's a lot of saving. So those type of things are there. Why I'm showing this flow chart, this was only required because the number of allocation we have done in pneumatic sinking, which is 7 to 8 times costlier, and it takes a lot of time, and there is a restriction also to do this. So this is the few thing. This is one again difficult well foundation which we were not able to sunk. We abandoned it. Later on, with the better wisdom, we have realized if it's not able to sunk, it's not a bad. It's a good for us. So if we take away that point, if the foundation strata is tough, it is a good for engineer. It is engineering friendly, I must say. So with that idea, if we propagate this concept, I think we can optimize the cost. Our project can go in a shorter time. So these are the few code drilling which we have been doing. So pneumatic sinking, I'll just few things which we have done, but now these are the few bridges which we have done. Bridges in Himachal also, then Karnataka. Incidentally, Havda bridge also we had done a pneumatic sinking. Then few other bridges in the country. These are the another few bridges. This is just a plugging we do after this. So I'll just give you a small case study of one of bridge. This bridge is 230 meter in near J&K. This is in Akhnur. During 1980, we planned this proposal, but there are 4 foundations in the midstream. If we see Chenab River in that area, it's very difficult to divert. Hard bank there, conglomerate strata. But when we place the vent portion, you can't go down also in this. But that time we were not able to, nobody was able to push us. If that is a good, it's a tough, it's a good for us. So now we are going with that concept. So then what we did, we changed this proposal. Then we further changed it to, finally we reached at a point when then the 2 pier are there, both the bank, P1 and P7, inside all the pier in the midstream in case of the flash flood. Then we abandoned the site. Later on during, I think 20 years, this fresh proposal was made without the intermediate pier. So this bridge was finally made, and this is in use now. This is just a final view of the bridge. Another bridge, this is one of the toughest bridges in the country BRO has made, 763-meter bridge in Arunachal Pradesh. This is one of the main tributary of river Brahmaputra. We call it Siang. This is coming from China. It's Sangpo river, they call it in China. So here also we had a lot of problem. Again, we were supposed to sink well 50 meter, but when we struggled for so many years, we carried out model study in between. After that, some revision of the foundation has done. But now as an organization, we are confident if the strata is tough, if this type of strata is there, even the consultant gave us 50 meter, we will not agree to this. Because we ourselves have seen, we have constructed, our engineers are working on ground. So those type of thing or knowledge which are available in the organization, we will certainly like to share with the students. So these type of boulder which we have taken out from this, these are the big boulders. And another, this was in this river also, the diversion was not possible. We had to do a sinking with the floating pontoon on the. This is the completed view of bridge. Now, with all this knowledge, what we did when we faced difficulty, bridge which was supposed to take 3 years, we have taken 8 years. So we thought if there is no cover formula in the country, why can't we try for this? So we made a team of engineers internally. We collected the data of existing bridges in the country with PR on bold rivet. Then certain parameter was decided. And before that, we had seen how this Lacey formula was developed. So we had seen when Lacey developed this formula, they had a data of around 17 bridges in Punjab. So basically, what are the factors? These are the factors which affects the cover assessment. So we kept this in mind. Now this is the existing formula which we are using as per IRC 78. Now the value of DSM which we are taking, and same thing is being right now. This is also being applied for the gravelly soil also. The maximum KS value is 2 to 2.4. This is a heavy sand. When my strata is a gravel heavy boulder, so it cannot be heavy 2.2. So based on the recommendation of BRO, the IRC has now changed this to 9. The latest guideline on this code is the value of silt factor, which we can take up to 9. So this is just to again amplify that if the same LWL is there, what is the strata around, if it is soft soil, and opposite side is the gravelly soil, sorry, bouldery bed. So you can see the erosion will be very less and the depth will also be less. So if that concept is very clear, then I think should not be very problem. Then to bring it to in a text form, so we had done some data collection. First of all, just to explain how the scour happen in poultry bed. D is the depth of water in the cross section, and DSM the value of scour, which I calculate from the existing formula of IRC, that is 1.34 dB square. Then this is the another alluvial soil. Now here you can see in when everything is raw right, formula is okay, DSM will be less than D. That means if DSM value is less than D, there is no scar. Because whatever we are calculating with the formula, the depth is coming less than that, depth of water. So when there is erosion, there has to be something below higher than the depth of water, which is the D. So that is how to neglect that this formula is not applicable for gravelly and poultry soil. Then there are, this I am talking based on the analysis of the cross section which we have seen on the bed. Then there can be a situation where DSM can be equal to D. Then of course there is an actual situation where certainly DSM value is greater than D. That means there is a certain erosion is happening in this. So this is the one table we developed. We took a fixed discharge of 50 cubic meter per second. If we keep a value of silt factor changed with a certain fixed discharge value, you can see how it is happening. As the value increases, that means as the size of material changes, the value of scour decreases. This is the first thing which add confidence to the people that whenever we are working on this, there is no need to worry. Whatever is written in literature, we can see, but certainly. So this value will reduce. Then further, these are the few model study which we have carried out in one of bridge, and those results are also kept in. Now, why this gray area is there, because there is no ability of formula adoption of Lacey formula purpose we were using. Then wider channel it yield uneconomical result. Then this is what is happening. The left side bore log data is what has been given to me by the consultant based on his investigation. When I go to the ground, when I dig a well of 12-meter dia, this is the strata which I am taking. So this just to indicate the green color is we had done the open graving. The pneumatic sinking. Other one was the pink color is that open graving we had done. The green was the pneumatic sinking we had done. So this is one of the bridge in Arunachal Pradesh. It was made in 1967. So this was a condition in 1997, and later on there was some issue. So we did. This is another bridge where the approach got washed away. There is no scar in the main pier. This is another Pasigat bridge which we have observed now after around 18 years. This is the cross section which has affected with the flow. Now there are two bridges very interesting. One is this Chalti bridge. We had seen the photograph earlier also. This is a Kijpura bridge. This is in J&K from Srinagar to Sonmarg. Why I am showing this bridge? During 90, we decided to make this bridge. Again, problem, not able to sink. Tractor abandoned the site. And we were also bent upon you have to go down site because it is given in the document and this is required. Since it was not possible to do within that cost and time, so this site was abandoned. Later on, we made a single span bridge. So this toughness was because of strata, which we had not taken positively that time. Now, that is what I am insisting. If such things are there on ground, this can be very helpful. This is the now, we had collected data of few bridges, physically checked the depth and this cover hole. Then this was the table which we had made for the data collection. Then somehow with the specifically few bridges we had ended. Now we try to correlate that whatever the cover in any pier has happened from the lowest well level, how much deep it is, numerical value, what is the numerical? Suppose this velocity in the channel is 8 meters per second. From the lowest bed level, whatever the value of scar I have taken, it is around 5 meters. Similarly, this has been checked for number of the bridges. We have find whatever the numerical value of velocity in any bridge in case of gravelly soil, the observed cover is always less than the numeric value of velocity. So this is with data of you another bridge. Then based on this, we develop few postulates how to go for it. That of course is a turbulent observation specific. Then flow pattern takes certain turn. Then one assumption is taken. Whenever I talk boundary weight as per international code also, size of predominantly material more than 50% should be more than 254 mm and above. Only then that river will be treated as a boundary weight river. That is the one. So another thing in our concept, this has to be measured from the lowest well level. Our formula which take cover depth, it is from HFL. If you see American formulas for this cover depth, they are from the lowest well depth. Then these are the few observation of this. I'll just come straight to this. Then since I told you that it is the depth which we have observed, it is very close to the numeric value of the velocity. So we had taken this concept that the lowest from lowest value, whatever the possible scar in any boundary weight pier is equivalent to velocity value. Then we take a shape into account is a circular and rectangular. The factor can be applied. Then another factor which is possible to apply is the constriction of flow. If there is a constriction of flow in the channel, then also the depth will increase. So based on this thing, we publish one paper during 2004 based on this paper number 508 in IRC, which is highlighting detailed hypothesis how we have gone based on model study, data collection and all this. So this was given, then there was few questions that your formula is empirical. Then we saw our own, right now, whatever the formula we are using, that is also empirical. Here also, that is also not dimensionally homogeneous. Then we come to the very close. Since results are very close, then we signed a MOU with IIT Roorkee 2020 on this. So we give a bridges which are on ground for modeling. Already bridges in service. So those bridges was given and the report which we have got from the IIT. So the results are very close, whatever the formula Bureau has given. So this is very close to. This is the paper number 508 and available on net. You can go through exhaustive paper on how we have gone for this. Then this formula is now in few books. This is Punuswamy books there, the formula is there. Then IRC based on our thing, they have changed this factor 9. These are the modeling of the bridges which was done. We had been to the institute to have the look to this. Now, based on what we have done, few things I just want to share with you. That bridge construction, of course, is a specialized field. We need to have a very close planning. Investigation is another important area which we are seeing, especially the soil parameter. Then in during construction review is very important. If the foundation is getting delayed, I just want to share with you, there's one bridge in Delhi near ISBT that was started 2004. This is very upstream of Lothian, old Loha Pol, we call it, near Red Fort. So that again, there was again issue of the foundation construction. But later on, that well foundation was converted to pile. And that review in between is a very important that we can do faster for the early completion of it. Then documentation is, of course, is very important. We can do this. Most important, the all people, it's not only that the knowledge of contractor should be high, we should be just sitting. People in the department also should also have a very good knowledge, because we can become a very good monitor to the project. Otherwise, it is very difficult, decision making become difficulty. Then again, the lesson learned we can compile and can use for future. Now, another thing we have suggested in the ministry also that launching a project, net-based, web-based project for scour assessment is very easy. If we take a task that all the bridges on Ganges from Haridwar to this Patna, if we want to observe there what a scar has happened, only 2-page performance is required. They are located in different division of PWD in the country. One executive engineer may get 1 or 2 bridge. They'll just fill the data. It will come on our program. Then we can view it. We can see how much scar is happening. So by this is, if we go web-based, it become very easy. And we have to see, should we go 50 meter for all the cases? Yeah, so much money is going. But this work need to be done. I think if the institute can take a lead and we can think of doing this project. Then the discharge calculation also. Now all the formula with Deccan's formula we are applying, they are all central part of India. When you talk of maximum damages are happening in Northeast and in J&K, all hill area, but no empirical formula is there with us. We are applying Deccan formula, that value of C and N. No relation. So we have ourselves are now working on this. We have a data of discharge of around 100 bridges, because I was heading that bridge and tunnel division of border road in Delhi. So a lot of data we had compiled with. So this work is very important. This can optimize the cost. Then existing bridges should be live model. Why I'm saying this? This is very, very important. I can do a modeling in the institute, but you will agree with me, the model cannot be replica of what actually is there. There are many abundant bridges of PWD or another in the country. If we take those bridges, discharge is going every year. Why can't we model those bridges? There is no expenditure only. Simple permission is required. Our student who is, we can do modeling also, but we can integrate with the practical things also on the field. That can give a very good result. And in that also, if your help is required, we can do this. Thank you very much. I have finished. Okay, some questions? Any question, anything? I would be happy to have.
Empirical formula and the actual in the field.
No, I will, because what we had, we were otherwise in our case, like we have done data of 20 bridges, only 3 bridges are there which are not coming very closer to this. So generally 87 to 90% result are very close to what the scar is actually there. When I anticipate the data of the bridges which are to be made also. So now we have applied this formula, like if you give me any bridge which is already made on boundary bed, whatever is the data, let us apply what we are suggesting, the result is likely to be very close to this. But only thing I think we also from the seeing a lot of time when is just a common sense, we have been seeing that when there is a gravel packed, cannot be like what is happening in sandy soil, something like this. But this need to be quantified for the benefit of engineer or departments.
Yes, sir. Thank you. Thank you.
Thank you, sir, for your lecture. Sir, I have a question regarding your inaugural speech. You said in Khuni Nala, Jammu and Kashmir. Sir, I am working on the same stretch. You said the BRO has made a buffer zone. which
Buffer
can-
zone, this is buffer. Buffer in the sense we put a rope from this end to this end. This was a top hill. The boulder was falling this. So downstream was my road and bridge. So those buffer was in such a way. First, you have a 3-4 rope. It is a triangular 32 mm dia. Rod are there. The boulder used to hit there. Then it will fall straight. Will not go to the road.
But sir, in last March, we observe rockfall on the portal of, there is a tunnel, if you have seen that.
But that tunnel is different because our site was upstream of a existing bridge. Bridge name is a Kuni Nala Bridge. That was.
Sir, that hanging bridge that you are telling about, the net and it is sufficient support? I don't feel so because there is only the kinematic analysis show wedge failure type and other classification which I have studied. Everyone is showing partly stable. Rock condition is very good. It is nice. So how can we determine whether it will be stable or not, or support is sufficient?
No, this is a flexible structure. This is closely integrated in the net series of that shape of angle iron grid, network. So our thing was if out 80 to 90% also we could save the large boulder if it just to dissipate energy initially and it should fall vertically instead of going down. Like boulder will be falling from the top, it will go with the slope and will fall on this. But now it has some hindrance in between. The pattern of fall will change. That itself was advantageous to us. So this has saved a number of times the things. Now, of course, with the 4-lane thing, this little disturbance of route will be there. But for study, this is available on ground.
Thank you, sir.
Sir, so sir, you have mentioned several projects. I just want to ask which one was you find most challenging, and if you can give some insights of that. Which project of bridge construction you find most difficult in your life, sir?
Yarrow?
Yes.
Yes. Yarrow, of course, because Atal Tunnel was the most important project because our whole pride was, as an organization, was linked with this. Because I just want to share with you that tunneling in the country has started in a big way after 2000, when we started metro. Before metro, we were having a lot of tunnel in hydro sector. But in highway sector, tunneling was started after the metro has started. So since when we started Atal Tunnel, we did study from 2000 onward. Then we awarded work in 2010. Took almost 10 years and 4-5 years was in Sri Nala. When we as an organization faced problem, we consulted everyone in the country, most of the institute. Then a few experts from the foreign country. Later on, it came to the conclusion that our own engineer in the country gave a better solution. But only thing is, since we have not done it, we were a little fearful. As I am mentioning about this cover study also. Imbibing a confidence is only possible when you do something actually. And that is what that experience has enriched us in a big way. Now we are taking tunnel in such area, there's hardly any fear. We are aware that if something will come, we'll attend to it. In the country also, a lot of people are now available. There are a lot of people who have done a hydro tunneling, but they are coming to the highway sector. But the requirement of highway tunnel is a little different because cross sections are wide compared to the hydro. Railway tunnel, the cross section again is very small. But in highway tunnel, this is the only thing, and this is the close project for us. Another thing I must share with you, it has given a big name and fame to the organization, Atal Tunnel, because nothing has happened during construction. It got delayed due to the problem, but certainly because we get integrated with a lot of institute, people are consulting us, and we'll certainly such type consultation we'll like to continue in our Sela tunnel, which is likely to be inaugurated at most probably end of February. So that was the main project which is closer to our.
Jain sir, I'll not ask, but I'm just to add. I'm Colonel Shaumendra Banerjee, and the two projects that sir showed, Pasighat Bridge, I was the engineer in charge there. And I was commander in from Ghatiabaga to Lipu Lake. Gave connectivity to Kalash, all courtesy sir and the guidance. One thing I want to bring out here, as a geologist that we are sitting here, right at the time when we are, conception of the project is there, alignment, disaster will never happen. If you notice at the British time, the alignment always used to follow the ridge lines, minimum slope cutting. But now we are cutting, but at the same time, we have got technology. Like Simfer is here. Simfer came up and they gave us how the blasting technique is to be done. Random blasting will create disaster. Systematic blasting will create roads, safe roads. So thank you, sir. Thank you for the details that you have given. Thank you.
Thank you very much. And once again, I'll invite all of you to visit our site. Anything we can do for you in data or other to show our site will be pleasure for us. Thank you.
Thank you very much, sir, for the enlightening talk. And I'm very sure that our researchers would definitely love to reach out to you. Now, I would like to request our Honorable Director, sir, Distinguished Professor T.N. Singh, sir, to present a memento to the honored guest.
Thank you, sir. Pleasure coming here. Thank you. हाँ कोई नहीं इधर हाँ अच्छा हाँ ठीक
कितना टाइम भाई आएगा अभी डाउनलोड हो रहा है नहीं अभी हो रहा है सब देख रहा है नहीं नहीं वो दूसरे अनाउंस कर दीजिए तब तक कि ज्वाइन कर रहे हैं है ना अनाउंस करने से ज्वाइन कर रहे हैं तो देख लो क्या नेट है आप अनाउंस कर
Ladies and gentlemen, next we have Professor T.G. Sitharam, the chairman of All India Council of Technical Education, Government of India. He'll be joining via online mode shortly.
हाँ हाँ चलो शेयर करिए इसको हाँ ये देखिए
उधर से भी शेयर कर रहे हैं
हाँ वो कर दिए मेरा
कर रहे हैं,
ठीक है कर दिया अनम्यूट करो अनम्यूट
सर
उनको अनम्यूट करो ना,
उनको करना पड़ेगा
इनको अनम्यूट करो।
वहां से करेंगे ना
नहीं तो आप करिए
यहाँ से अनम्यूट करिए ना इनको। ना ये इस पे क्लिक करिए। हाँ यहाँ पे क्लिक करिए।
सर उधर से वो कर सकते हैं
सर you have to do unmute you have to unmute yourself
सर कर दिया
यहाँ से नहीं, request ही कर सकते हैं यहाँ से।
कॉल कर दिए
हाँ we can see you but we cannot hear because it is mute from your side
सर इधर से उनका आवाज जा रहा होगा इधर से उनको जा रहा
yes sir हाँ
है। सर यहाँ से तो सारा किया हुआ है अनम्यूट ऑल कर
sir
दिया।
your PPT is muted you are muted from your
सर ये
AICT headquarter I have sent request to unmute again okay hello yes sir okay
उधर से ही सर से
so I think I'll put the phone on the speaker then you can talk it is better because it is not coming in the system your is showing unmuted नहीं उनका नहीं आ रहा वो कह रहे हैं आपसे बात
हाँ हेलो
उनको बोलिए ना स्पीकर इस पर रखें
इनको तो अनम्यूट ऑल किया हुआ है यहाँ से भी कोई दिक्कत नहीं है मीटिंग लॉग
वो अनम्यूट उनको बोल रहे हैं बट वो कह रहे हैं हमारी तरफ से है
अनम्यूट कर दिया
खुद ही कर सकते हैं
क्या बोलो हेलो
या सर उनको बोलिए ना कट करके रिज्वाइन करें एक बार
हाँ sir, you cut and rejoin sir.
ड्राइव कर रास्ते में
इसके बाद किसका है उसका पीपीटी आ गया बताओ और उसके बाद एक मेल इसमें मैं अब तो खोल ही गया
Can you hear me?
Yes, yes sir, we can hear you.
Can you see me?
Yes, yes, we can see you also.
Okay,
But
fine.
you share the PPT, please.
I will do that. You're able to see my presentation?
Yes, sir, you can start. You can start, sir.
Yeah, I will do. Very good afternoon to all of you. Namaskar. So first of all, we congratulate Iit Patna for organizing this conference on geotechnical issues in infrastructure and energy sector. Okay, and first, today's talk I've titled it as geotechnical issues in infrastructure and energy sector. And I'll focus on several case studies where we are dealing with the rock mass. Okay, so this is about one can clearly see the challenges in geotechnical engineering, where we study about a lot of delves into a lot of intricate world of varying soil. So these challenges ranges from characterization of the soil, rock mass, along with instability, to environmental consideration, maybe climate change and many other things also, which demands an innovative solution to ensure success and safety of infrastructure projects when we deal with such projects. Okay, so here I'm going to highlight some of the issues where, starting with site characterization and soil and rock properties, it may be also in the design, and then construction of features where you're going to do either stability issues or groundwater management issues, or even underground openings also I'm going to touch upon, which will address the tunneling challenges. Okay. And as you know, you are in a conference which is very important for considering the infrastructure and energy. So here, these are vital components of a country's economic development, providing the foundations for industrialization, urbanization, and improved quality of life. So here, I'm going to emphasize in our case study the importance of geotechnical investigations and also advanced modeling techniques, and it should be simple but elegant, techniques, and on ongoing monitoring also. See, today we need to also learn what we have. So that's real, components of a very successful infrastructure and energy project. So here, what we require is a collaboration between geotechnical engineers, structural engineers, and environmental specialists. And this collaboration is the key. And that is how the large projects which we are now doing it requires more than one discipline or one specialization. So let me come straight to the problem, and then I will take you to the case study. See, particularly when we deal with the rock mass, when we are going for large projects, this is very inevitable that you are going to meet with rocks. Here, what we call jointed rock mass is it's a very complex, actually. It is is much more complex than even soils, because the scale at which you are dealing the problem whether it is a fissure, joint, fracture, or faults, how do you handle them is a very critical aspect. And their frequency and the type of joints, orientation of joints, joint roughness, strength of joints, and also whether the joints are filled up with some material, so the type of joint filling, and then the confinement, the in situ stresses are also going to play a major role in the behavior of these muscles. So, and challenge in rock mechanics is obtaining an undisturbed sample of a rock mass and testing them under laboratory conditions to obtain the parameters for modeling is a very difficult job. So that's where it differs from other materials, other civil engineering materials. Strength and deformation behavior of the rock mass is also highly stress dependent, very similar to the soils. But at least soils, you can take a sample and bring it to the laboratory, conduct under different stress paths, and have the parameters ready and develop models and have a constitutive model, and it can be attempted. But here, so in addition to that, my construction project will have a staged excavation or staged construction, where each of the construction stages have to be also modeled and predicted. And construction also has to be done carefully after your design. So the existing models in the industry are very complex. They go into mathematically too much. But what is very important is very simple model, but captures all the stage constructions features. So we need, in a complex model, we need large amount of data, both from the experimental and field testing. But here, what I'm going to show you today is going to be a very simple hyperbolic model, wherein we are going to capture the rock mass behavior and use them for a real practical problem where stage constructions are also being simulated. So this is what I'm going to show you. People, because we are dealing with nature's material. Nature material varies from point to point. So it's more than mathematics. Meaning your model has to be very simple, so that you can capture the behavior and understand the global picture when you go for a construction. So I'm going to take the input. So before that, I just wanted to show you how we develop the model. See, for a block jointed specimen, sorry. See, we have modeled this block jointed specimen by considering an equivalent model, okay, where we have actually adopted into mathematics of the details of this. If somebody is interested, they can read our papers. This is based on actually Professor Ramamurthy's work at IIT Delhi. A lot of experiments have also been done, verified, and we have published, extensively in International Journal of Rock Mechanics, Mining Sciences, and many other journals. So, so some of you can actually take this. This model is available for anybody to use it, and we will also ready to share this model.
Sir, you are at slide number 4. Is it okay?
Is it?
No,
seeing, it's not okay.
We are seeing.
Yeah, it's correct. It's correct. So the block jointed specimen, are you seeing?
Yes. Slide number 4, tunnel and the roof of the cavern.
No. I think it's.
The title is Behavior of Jointed Rock Mass.
That means something happened. So let me see.
So you have to unshare and share again, I think.
I will do that. You are able to see now?
Yes, number of slides we are seeing.
How about now? I have projected now. I'm in a PowerPoint mode. I'm in slide mode.
This is the first
Single
slide.
slide.
We are seeing the first slide.
How about now?
Geotechnical issues in infrastructure energy sector, slide number 3, 4. Again,
5. Okay. This is what I was actually talking. Okay.
4, slide number
This is
4. Okay, okay.
Yeah.
Now we are
Block
seeing.
jointed specimen.
Now we are showing block jointed rock. We are seeing.
Thank you. Thank you. So we actually modeled this block jointed specimen from, we have also conducted an experimental in a laboratory where, we try to simulate this instead of modeling each joint. We were modeled this is an equivalent continuum based on joint factor model. So let me not go to the joint factor model too much here today, but I would like to show that this joint factor model actually predicts reasonably well the behavior of joint rock mass under different in situ stress conditions. So we have compared with a lot of experiments, and this model was developed. And once this model was developed, we have applied it to several projects at site. Let me first to show you this presentation talks about design as you go approach. In geotechnical engineering, we need to design the structure, as we excavate or as we construct, we need to relook at the loads. That's more important than what kind of constitutive model you have used. Okay, that is stage construction, stage excavations are very, very critical. That's what I'm going to emphasize. So we need to completely design the restructure of the design. So continuously with the inputs, what you are getting, maybe a new parameter testing, soil test, rock testing at site, and like load tests, cyclic load test, and all these test results brought in, and then we have applied it to the large problems. And I'm going to show you slopes and excavations and also underground constructions. So this interactive design, what I call it is observational method of design, which is actually practiced in tunneling quite a lot. New Austrian method of tunneling is quite popularly uses the interactive design. This is also, there is a technical committee in soil mechanics, ISMGE, to consider how to interactively design the structure. An interactive geotechnical design is a design approach that requires design refinement throughout the project execution until a suitable technique and an optimum scheme are applied to the problem in hand. This is what we are going to practice in major projects of ours, which could be highways, railways, power generation facility, mining, or residential building. Friends, let's take some case studies. Design is being applied for several cases, so which will establish the for particular project how to do this. So I am going to take a case study of slopes, excavation, and underground. So let me come to straight away to the case study. So I think many of you have seen these pictures, very, very attractive pictures of a Chenab Bridge, one of the highest elevated rail bridge in the world, which is just constructed and completed by Messrs. Afghans, which is a Shapurji Paranji group, in very close to in the state of Jammu and Kashmir, very close to Katra city. So you can see this project alignment. What it does is it connects the mainland of India to Jammu and Kashmir. See, if you look at the red portion of the alignment is actually not yet done. Chenab Bridge comes right there. See, there is already the blue line, which is an operating railway line in the valley of Srinagar from Baramulla to Banihal. And from Jammu to Katra, already the lines are operating. Recently, in 2017, Udhampur to Katra was launched by Honorable Prime Minister. Today, those who want to go and visit Vaishno Devi temple, many of them can travel up to Katra by train. So the distance between Katra to Banihal is about 111 kilometers. That's a very treacherous route because of the geography or geology there is very, very complex. So this distance of 111 kilometers now is mainly connected by several bridges and tunnels, and these are all almost in the finishing stage. Right now, the Chenab Bridge is ready, and that is what I'm going to talk to you about. In the Chenab Bridge, I was associated from 2004, very early, and until 2019, where we did the entire slope stability and foundation analysis and also the design of the entire structure. You could see now the entire project took almost 15 years to do, but the entire superstructure, the bridge, is being done in 1.5 years. Okay, so that means very clearly shows the challenges in the geotechnical problems, and that is the theme of the conference, the challenges. And how did we solve this problem? So 15 years is a very toiling experience. I might have gone there maybe 3 times, visit to the site and interacted with railway board and everybody, so that we can convince them this bridge is doable. The bridge is 354 or 362 meters above the water level, and it is taller than the Eiffel Tower. Okay, you could very clearly see, which has a left abutment and a right abutment. On the left abutment, there are all these pillars, and then right abutment also, and there is also an approach bridge, which is close to about 530 meters. Okay, so these are the bridges. I have shown you the cross section, the initial and the final. Initial and the final cross section, what we have arrived after the design as you grow approach. This is where I wanted to highlight design as you go approach. Just 1 minute. In the design as you go approach, you can very clearly see the final cross sections adopted. I'm going to show you in a little while how we have designed this in a stage wise and looked at it construction feasibility as well. The statement was it is a highly jointed rock mass. That's the model what I have used, predominant in the Himalayan region, where the ground is all younger dolomitic stones, and was subjected to severe tectonic activity due to pushing of the Gondwana land into Eurasian plates very close to the main boundary thrust. The seismic activity is still present, and a lot of landslides have happened here. Highly jointed rock mass is close to the soil. It's almost like a soil, but from strength point of view, but yet the behavior is governed by joint characteristics. This is the younger dolomite, as I told you. The analysis of slopes and the assessment of safe bearing capacity of foundation coming on the slopes involve elaborate work treating the strata as a continuum, and on one hand, and as a discrete material on the other. So thus the analysis become a very cumbersome and very expensive. So we have done continuously as we excavate, we find out new properties, newer cross sections, and did the analysis continuously. Hello. When I talk, can I speak to you later? I mean, I talk. Hello, can you hear me? Somebody can confirm? Hello.